Good morning, everyone. Well, welcome to our uh, third now training session for HPC in the city. Today, we're actually going to be covering our Google Cloud platform. Believe it or not, we're only 3 weeks out from the actual event. So we have a total, including this training, well, after this training session, two more training sessions before the actual hackathon begins. As always, we want to give you a little bit of initial information before we go into our training session, just to answer any of those initial questions. If this is your first training session, we want to welcome you. We have a couple other training sessions out there that are listed on the site that, of course, you can take a look at your leisure. Last thing I want to say is that we only have a few more slots available for students and for mentors. If you are considering signing up for the hackathon or have a friend that you're like, hey, buddy, I want you to join, they were like, yeah, that sounds cool. Tell them do it today to get it done so that not only are they registered for the hackathon for HPC in the city, but so that we can also get them registered for the conference itself. So today's agenda, of course, we're going to do some quick introductions. We're going to go over the hackathon objectives, the deliverables and resources that you'll have available to you, some general information, and then we will begin our Google Cloud overview. Now, before I hit next on the slide, I always love to see your smiling faces. So I am reaching over in the corner of my screen, opening up so I can see plenty squares there of bobbing heads looking at me. How you doing? Over there in the corner. There we go. All right, so moving on. Our organizers for the hackathon, we have Alex, who is actually over in Estonia, Boyd, who you'll be hearing from today, Amy, are you here? Would you mind saying hi?
Hello.
We have Dr. Hayden. Doc, would you mind saying hi to everybody? Oh, she's reaching for it. She sees the mic button. She's going to click it.
Unmute. Hey.
And then we have myself, Jimmy Powell or Jamie. And Boyd, I would let him say hi, but he's going to be talking for a little while. So I'll let you speak to him here in a moment. See him smiling. There we go. So the objective of HP in the city is to utilize the resources of the high performance computing community that usually lands on a city during the supercomputing conference, and to then spread those skills, knowledge, uh, and experiences found out into the community in a way that will directly impact them. Now, this year, our theme revolves around developing an understanding of Atlanta-based issues and then bringing some type of application analysis or data management to bear on that particular issue. And that can range from a lot of different areas. What you should expect, though, and what you should expect to gain, or is an increased familiarity with data science in the cloud, experiences working collaboratively, including in software engineering and software development, and developing some professional communication skills along with that. And because it's virtual, all of this is going to be new and definitely applicable to today's circumstances. So I always like to take a second at this slide to make sure that everybody knows where they're getting into. With the hackathon itself, there's some deliverables that we expect each team of 4 to 5 students, along with a mentor and a staff member, to produce. The first is a set of source code, including comments in that source code about how it works. A PDF presentation that your team will present on the final day that includes team members' names and pictures, including the mentor, use or explanation of the use of HPC technology in their project, and then also importantly, regionally, in this case in the Atlanta area or Georgia area, the implications of that project. So how your project could directly impact Atlanta and greater Georgia area. All of those things should exist on a GitHub repository that your team creates with a readme.md file that includes information about your project description. Different resources you're going to have, of course, mentors, staff members. We have our Slack channel that if you're not a part of, please send me an email so I can send you a link so that you can join our community channel over there. It's open right now, and we are monitoring it as we speak. the Google Cloud provider credits, which you're actually going to hear a little bit about that today. Cloudy Cluster, which our training session for that is taking place next week. And just to also throw out there, some of our most commonly used software products are Python, Jupyter Notebooks, Node.js, so JavaScript, HTML, and then we of course have our data sets, which are available to you on the Hack HPC site right now. Now, just for me, I want to make sure everyone should see on their screen that we are indeed recording. Is that correct? I saw John put in the chat. Good. All right, we got thumbs up. Sometimes when you're on full screen, you can't see all the features. The 3 T's I also like to throw out there for everyone. It's a quick summary. Teams, 4 to 5 students with 1 primary mentor and 1 specialist. Just to let you know, the mentor may be a student. We do have a student mentor that's a part of the hackathon. We may have 1 more. Time. Right now, it will be taking place, the draft time, we do know will be taking place from November 5th to the 9th, with the first session on the 5th at 6 p.m. So we can do the event start, which includes team formation and project scoping. You'll have at least 2 check-ins per day for that Friday, Saturday, and Sunday, with possibly 1 additional check-in on Monday, the 9th, and then final presentations at 6 p.m. Eastern time that Monday. Topics can include anything from data management or data analysis of COVID-19 expansion, economic disparities, or effects on college participation, genomics, weather, social justice, presidential election. That one might be important because the presidential election will be taking place November 3rd and the hackathon that Tuesday. And we start that next Tuesday, or as my mom used to call it, T-Day, on that Thursday. And this year is a little bit interesting, as you all know, as well as graduation rates, broadband access, insurance rates, and the list goes on and on and on. And I want to make sure I say, if there's something that you don't see in these example topics and you have a great idea, like we heard one yesterday from an environmental group that is has actually signed up to be a mentor, please let us know. And if you, a student, have an idea, let us know. We can support you in that project. So having said that, I get to stop being the talking head and I get to hand everything over to Mr. Boyd Wilson, who will now give us an overview of the cloud platform. So Boyd, the stage is yours. Now, I do want to say one thing about Boyd. I've worked with Boyd for a few years now. Boyd is a part of Omnibond, which is the vendor company that has supported our hackathons since the beginning back in 2018. Boyd and Amy, along with Josh and Rich, have been a deep part of the hackathons from the beginning. And yeah, he's a very special guy. So I'm looking forward to him doing this presentation for you. So Boyd, I'll hand it over to you.
Okay, hey, thanks, Jamie. It's always hard following Jamie. He's so exciting and fun to listen to. So I have full special effects in the background. You might hear saws and hammers. Maybe it's because it's Halloween, or maybe it's because there's some repairs going on. So I apologize for that, but I'm excited to talk about this. So instead of just adding more slides to the deck, I thought we would just go through and talk about the cloud and Google Cloud specifically. But I wanted to start with just saying that what interested me in the cloud many years ago, I actually went to a talk early on with some of the people who are starting to build the infrastructure of the service platforms. And this was a long time ago. And it kind of intrigued me. And then as I watched it, it was interesting as they built these systems out. And when I say cloud, I'll be focusing on infrastructure as a service. There's platforms as a service. There's, apps as a service. And so there's other things, but specifically infrastructure and the service has changed the way things happen in the world. You used to have to be able to afford a data center to be able to do any large scale infrastructure app. And if you think about how the world has changed over the last decade, small startups have been able, see full effects for Halloween with the saw in the background, have been able to start up with just using a little bit of the cloud, and they write some code, it spins up some VMs or does some other things. And then as they use grows and they, get a little more money and they can scale their service. And these APIs and all these other things are a rich set of, it's not just spinning up VMs, you get the whole API driven infrastructure. And that's the really cool thing the cloud has enabled. And it's really exciting that anybody at their fingertips with not a lot of money or a credit card can spin up apps that are pretty exciting. We'll touch on various of those different things, but I also want to show you, I'm a type of person, the internet exists. I want to show you where the things are, look for the caveats, and give you the tools to go research and study what's interesting to you. And as always, you have my email address. It's just boyd@omnibond.com. If you have questions, shoot an email and try to find the right person to answer it if I can't answer it myself. So specifically Google Cloud, one of the things you always have to worry about and think about and understand is the cloud costs money. When you buy servers, you have a sunk cost, it's fixed, and you may not worry about using it as efficiently, but when you're using the cloud, every time you're efficient, you save yourself a few cents. So it's always good to think efficient and optimize for cost in addition to performance, in addition to all the other factors. And this is another thing the cloud has brought. A decade ago, when I used to run a really large data center with a large HPC system, not as large as what Jamie and the folks over at TAC run, but you kind of just, bought it and then you tried to get people to use as much as you can. In the cloud, you kind of add that cost, not as an annual item, but as an ongoing thing. So one of the first things I want to show is, this is one of our accounts at Omnibond. And you notice we did a lot of stuff last month and we burned 8K. But you have to look at this and you have to track costs and you have to think about costs. And essentially you're turning a lot of CapEx that you're investing in hardware into more of an operational expense. And if you're not careful, that operational expense can run away from you if you leave things running and you're not worried about it. But so there's what's called a billing account. And this is where you tie your credit card or you tie some credits or your company or institution. This is, they get a bill every month and this is where it's paid and it's all tracked in the billing. And so there's one billing account for Google Cloud. And then once you get that billing account, you have to link it to something where you can actually go do stuff. And what you actually get to go do is, and we'll just switch to one of these other ones, what are called projects. So you can have one or many projects. You see there's kind of the Omnibond parent thing. And we'll go ahead and say, hey, let's create a new project. And we're going to call this SC20 hack. And we're going to assign it to the billing because you can have multiple billing accounts. And then that's the organization, and then you create. And then as that's creating, we're going to go look at that project. Now, if you noticed on the previous screen, the next level is, okay, I've got this project. How do I give people access to it? And if you notice, there's a couple of default people who get access because the way we've configured things in the system. But if you wanted to give other people projects, you would then go what we do call IAM, and we would add a user. And so this is a member. And what's cool about this is anyone with a Google account can use that Google account to become a member. So you don't have to create new user IDs and passwords. You're just linking this to a Google account, which most people already have some sort of Gmail account or something like that. And then this is how you add members to the system. Now, what we're going to do for the hackathon is we're actually going to create a project for each one of the teams. And Google's been kind enough to give us some credits so we can actually, people can use Google Cloud and Cloudy Cluster and whatever else they want in there for the hackathon. And the one thing to remember is they've given us a fixed amount of money, and these projects will be created in this, just like this SC20 hack, we will be creating, a project per team in this same thing. And if we run over the 5,000, it comes out of, Omnibond's pocket. So respect the spend. And we have enough. We don't think we'll run over. So don't not do something. But if you think you're going to do something big, it's okay to ask. Just ask the question. We'll probably say yes, go for it. But when I say big, launch 1,000 GPUs and leave it running for the whole hack, you're probably going to use up that and some others if you talk about the really big GPUs. So this is how you add members. And if I add, I could add Jamie to that and then select a role. Now, this is where you could give them specific privileges. Now, IAM is set up to show, you could do all kinds of granular access at the different levels. You can give the people billing or whatever, but let's say we just say, Jamie, you're going to be the project owner. And that means Jamie can do everything. And then send Jamie an email, and then we'll say save.
Boy, did you just give me a credit card full of compute power that I could do anything I want to with?
Yeah, see, respect the spend. Yes, I did. So that's IAM. So when we were creating these projects and accounts, this is what's happening behind the scenes. You won't have to worry about this, but if you want to do some Google Cloud stuff on your own, you will have to. And we wanted to kind of give you the background. We're going to let you pick up where things, we'll have all these set up so you don't have to mess with it. But this is there. But if something's not right, we'll give you owners. We're going to give the team members owner access to that project. And so you can, be careful but have fun. I think my dad used to tell me that. Sounded like my dad now. So there I've seen billing. I got my little checklist here. You've seen accounts. Now, the first thing people think about when they think about the cloud is spinning up computers, because, we all have little laptops and we might have servers that we have access to, but a computer is a thing that, we're used to. So the first thing people think about is a VM. So I brought up the documentation here, because one thing that's really interesting is I like how Google's done their documentation. And if you want to do stuff in the cloud, GCP, this is how you want to go through. So creating and starting a VM instance. Now, after you get used to this, if you understand the concepts, okay, I know what a VM is, just show me the how-to. Scroll to the bottom, you know what I mean? And then you'll say, you get different options, say creating an instance from an image, and they give you options. Here's the console, so you can go to the images page. I want to make sure I didn't go too far. There's also a G-Cloud. Now, G-Cloud is a command line tool. If you know the answers and you can type fast, G-Cloud is faster than trying to navigate through the console generally. Then if you want to do something in your program, and when we show you Cloudy Cluster next week, we did all of this stuff through the APIs. So that's the different things that you can go through. And then there's a set of permissions, and they'll say, okay, here's all the permissions you need to be able to do this. Now, permissions can get assigned to user. You saw me assign Jamie all ownership rights. I could have given Jamie specific rights to only, do some little small detail in there, or give him everything. Now, one of the things when you're developing or writing software, you want to write software from a least privileges access concept. What I just did to Jamie is not what you would do to a program. Now, what's interesting in the cloud is how do you give a program permissions? Now, one of the ways you can do it is you can download a key and put it on the instance, and then you can manage the key. But there's actually a cooler way. You can actually give permissions, just like I did to Jamie, directly to an instance. And when we show you next week, it's actually the instances gain the permissions to be able to do the other things like launch other instances, launch HPC jobs, and things like that. So you can give permissions to an instance, and that instance can then do other things. Now, as Cloudy Cluster as the example, we have one instance we call the control node. And it runs the GUI. So you don't have to worry about knowing or anything about Cloudy Cluster, but it runs the GUI. And what's interesting is we don't give any end users, when you're setting up users in that system, access to that control node. Only, you only can access it through the web UI, which we have locked down, or you can access it through the SSH keys. When you set up every instance, you set up SSH keys or project keys. And we'll get to that in a minute. But the real thing is, you set up and you want to develop from a least access capability. So when the login node's there, only people that have login privileges. The scheduler can spin up other instances, but other compute nodes can't spin up other instances. So you kind of set up these permissions to make sure things are locked down and only can do the things they need to do. So if some, script kid, if you don't, update something, which these auto update, but you have to be careful and think about security and think about someone owning your system. And the one thing to point out, when you're developing in the cloud, if you make an instance public, okay, when you're doing this for the hackathon, it is public. You put in a public IP address, it's out there, and it might have been an IP address that was used by some big site 3 weeks ago or 3 hours ago. They retired that instance, the dynamic IP went back to the pool and got assigned to your thing. So you're thinking, well, nobody will know about my stuff. And if anyone sees anything in any of these chat windows or anything that I need to answer, just yell at me and I'll answer it. Or if you have questions, just say it. But so don't just open up an HTTP service and then give it access to everything. So just be careful. And if you don't know what you're doing, ask. In a hackathon, we're here to learn, ask questions. And we're always here, but just think about security, and you're on the wild, wild west of the internet when you're doing this in the cloud. And so sometimes when you even get down here a little further, because I found this earlier. So if you click on the APIs, several options, several times you'll get actually different languages that you can leverage. And so you'll see Python, or you'll see C, or you'll see Java. So you can actually pick some sample code from those examples and see it. So now, let's go and look at, back at the console, there's this big hamburger menu up here. And this menu will let you go to all the different areas. So the next thing we want to go is, let's go to the VM instances. And notice there's no VM instances in this new project. Let's create one. Okay, let's not do it in this project because it's not ready yet.
Yes, I was trying to make a VM, but it wasn't showing up in my account yet.
So it's still setting up. And that's why some of these setup times, that's why we're just setting up the projects and existing accounts. We'll already install a Cloudy Cluster. We're going to do some stuff to make it easier so you can focus on your problem and you don't have to focus on, obviously you have to focus on the things around your problem, but not the infrastructure to get to your problem. So here we're going to create an instance. And Jamie showed a little bit about this, I don't know if it was last week or the week before. And when we do stuff, we try to name it. So when someone's doing cleanup, just because they're cleaning up some of their stuff, or they see other stuff running that somebody might have left, they say, hey Boyd, you left that thing running. Did you really mean to do that? It's burning $1 a day or whatever, $25 a month by the default.
So Boyd, while you're typing in the name, would you mind telling us a little bit about what a VM, a virtual machine is, versus an instance, and how they kind of come together? Because it seems like you're using the words synonymously.
Yeah, so what's interesting, AWS uses the term instance, and that means VM. They're synonyms, they're the same thing. Instance can be a little more generic. So sometimes I'll say an instance of Cloudy Cluster, which is a series of, if you've set up the environment, multiple VMs that act together to provide that HPC environment. So instance is a little more generic. VM is what they use in the menus and the commands here. and it just stands for virtual machine, and VMware probably gets credit for coining that, I think, but some people might argue that others did as well.
So what I'm getting here is that a virtual machine is basically a computer. For all intents and purposes, it's just a computer that exists in the cloud. Is that correct?
That is correct. And the way the cloud is set up, if you'll see the next option, there's regions. So there's regions and zones. And if you think about a region is kind of an area that they've put together where they have several data centers, and a zone is a data center. And so when you're choosing where you want to run stuff, you can choose several different places, including other countries and anything. Generally in the US, all the prices are the same. If you go to other countries, some of the prices can be a little more expensive. Power and other things are more expensive in those areas. And then the zone, depending on how big the region is, and the US Central region is kind of Google's default region, so it has more. And sometimes if you're looking for the newer things, they may not be in the A zone. You may need to go to one of the lower numbers. That's something we've learned until they do a refresh, and then they, if they get rid of some old stuff and they put some new stuff in. So if you're looking for certain instance types at scale, which you won't need, everything will probably have everything you need for the hackathon. But if you're trying to run a large HPC job, sometimes you need to look around, and Google's making some APIs to make that easier. There's something called different machine families. The machine families, there's like general purpose, compute optimized, and memory optimized. And if you notice, this one has 96 vCPUs and 1.4 terabytes of memory, so a little bit of memory. And there's even and that's the mega mem. I like that name. And then there's the ultra mem, but you probably don't need that much memory unless you're doing some sort of caching type application and caching a lot of stuff.
Lloyd, I'm gonna need you to say that name with more intensity and
mega mem.
Like mega mem,
Mega mem.
So you have accepted the truth.
Oh my
Yeah, sorry, I have this little machine tab that I'll use every once in a while during the hackathon to annoy everybody. So the compute optimized are actually the fastest, latest, greatest Intel processors. And you'll notice there's a 4 in there, and the 4 is the 4 vCPU, 8 vCPU, 1660 and through that. And for those interested, a vCPU equals a hyperthread, and there's usually, there's always currently 2 hyperthreads per core. So that kind of gives you an idea. And then, but general purpose and a couple of vCPUs and 4 gigs of memory on a Linux system will probably do most people fine, or even smaller. If you want to do just a little proof of concept demo for the hackathon, and then you can decide what kind of traffic you want to access. And this gets to the firewall rules. But if you know you want to spin up a web server and that's the only thing you need access to, and whether you're going to have a cert or not, it's HTTP or HTTPS. The one thing to remember, HTTP is not encrypted. That's port 80. But you'll just have to click a few extra things in the browser to let you have access to it. And if you have questions on that, there's also something called a service account. The default will be fine unless you're doing some of that permission stuff I was talking about earlier. So we'll go ahead and create that. One thing really nice about Google is the instances generally come up rather quickly.
So just to ask here why that instance is spinning up, while that virtual machine is spinning up, you said something about hyperthreading. So would you mind kind of explaining that a little bit?
Yeah, so when was this? Like in the 380s? When did they start hyper? Anyway, it doesn't matter.
686.
Yeah.
Okay. Pentium something.
Yeah.
Pentium. So hyperthreading essentially so that there's like pipelines in CPUs, and there's a core pipeline that actually does the computation. And then there's things that are waiting and doing stuff. So a hyperthread actually lets 2 of those things waiting kind of time slice for that core very efficiently. And some codes are very happily doing that because they're waiting on other things. And then it goes into the core pipeline for the compute, and then it kind of puts its result out. So a hyperthread is actually a very optimized pipeline into that core computation and out.
So if I say that back to you, what you're saying is that but you're saying a core pipeline of bring it in. So you're saying basically a workflow or the way you do something that goes into the computer, and then the computer can then spread that out or run multiple instances, or the HPC way, parallel process a particular application or program at the same time. But hyperthreading is what defines how many different processes, how much parallel processing you can use. Does that sound about right?
Yeah, and when you think of it, and you saw there was like a 16 vCPU, and that meant there were 8 cores on that instance. And so there's 8 cores. So when you're running processes, if you have hyperthreading on, it's going to say, okay, you have 16 things that can run concurrently. And it's going to do some efficient things to take 2 of those and make them work efficiently on that single core. But it really gives you double the throughput on a lot of workloads. There's some workloads that are so processor intensive that you're actually, the other one's just going to be sitting and waiting. And the hyperthreads have faster access to memory and, things like that, outside of that, ring zero is not the right term, but that, that operating, that core operating location. So we have that instance up and running. You'll see a very similar screen that lets you see all the information about that. And so then you can do instances, and there's lots of other things you can do with that. You can, and if you notice right here, this one only has a private address. So that means you can only access it from within where you launched it. And we didn't create a VPC or virtual private network here. So there's a default virtual private network, and it's in that, and it's 10.128. And anything that starts with a 10 is always private, and you have to go through NAT or other mechanisms to access in and out. When I spun it up,
you can only access that through the console. Is that what you're saying?
Yeah, you can only access it through the console.
Okay.
If you want one of your instances to be public, then when you're spinning it up, the easiest way to do it is to say, do that. Or we can go in here and edit it. And I think I have to stop it first. But you can actually go in and edit and assign it, but it has to be stopped to change that. And there's probably some commands to do that, but I won't waste everybody's time digging into that right now. But you can do those. This one's spun up on a Haswell. If I'd have chose the C2, we would have got the Sky Lake, I think, or Cascade Lake. Anyway, the latest ones. And then, so that's VM. So that's a computer running in the cloud. And one of the things, I just launched whatever generic image was there, but there are lots of images. And if we just go through the process again, and then you choose the image, and then let me see, image. So right now it's Debian, Linux 10, the Buster. But if you want to choose, you could choose different operating systems, all different kinds of things. You can even create a custom image, save it out, use that. And then there's obviously the different versions on that. And there's also some other shared images. If you go to the marketplace, there's images that you can use that have the machine learning libraries on them, or other base software that you can configure. So if you do Google searches on, GCP, image types, or if you go to the marketplace, then you can access those. So there's lots of options there. I just chose that one. So one of the other things I wanted to highlight, and there's lots of other things here, was storage. And Google calls this storage, Amazon calls this S3, and this is object storage. So if you go to the object storage browser, so we have some buckets out there. And most of these are just automatically created as part of Cloudy Cluster when we're doing testing and things like that. But there's a concept here. So this is, an easy way to store data in the cloud. And there's a couple of things you can do with it. But one of the first base thing that you create is a bucket. And I like it. You put stuff in your bucket, and then once you get your bucket, which we'll go ahead and do, Boyd's bucket, not Boyd's kick the bucket. And then we'll say continue. And you get some availability types. And there's different pricing associated to this. But the one thing, storage per gigabyte per month is, 2.6 cents. It's pretty cheap. And for what you're doing at the hackathon, you'll spend more money in compute by a long shot than you will in storage. Even if you're pulling down, a couple of gig data sets and leaving it there for the duration of the hackathon. Generally, you want to choose multi-region. What's nice about object storage is they actually replicate the data across region. So if a whole region becomes unavailable, your data is still available. And they get some serious nines uptime. And it's pretty interesting that the design that kind of brought this. And then you can choose something called a storage class. And standard is probably what you'll use for the hackathon, but just for, future edification, you also can do other things like nearline, cold line, or archive. And what's nice about these is if you have a bunch of data that you don't want to access, but you need to keep because it was some big expensive research project or something, now we're down to 0.4 cents per gigabyte per month. And that's cheap, but you're going to pay some access fees for that. So you don't want to choose that by default and then go access the data once a day. You're going to end up paying more than the standard. So there's kind of, if you notice these hints underneath, short-term storage, frequently accessed. Nearline is backups and data access in less than a month. So if you're going to keep, access something once a month, you put it nearline. Cold line, less than once a quarter. Archive is best for, I'm only going to access data once a year. So they kind of give you guidelines in there to do that. We'll keep this bucket as standard. And now there's access control. If you're creating, there's two options here. Fine grain means that you can go into every file or directory that you create. And once you have a bucket, you can do files and directories just like you do on your normal computer. And you can have permissions that go to each one of those constructs. Or you can say, you know what, this is going to be a website and I just want it to all be uniform. So there's only one permission that rules them all. We'll just leave it fine grain because that was default. And then we'll say create. And so we have Boyd's bucket, and now you can upload files, and we'll find something on my desktop. There's a screenshot from something I watched yesterday. You can just drag and drop these puppies in there, and then you have your file uploaded, and it's sitting there. So there's that screenshot that I did of something yesterday. One thing interesting about buckets is you can use it for data storage for your internal purposes, or you can create a website out of it. And so you can easily convert this to a website. We go to Boyd's bucket, and there's these ... and then you can edit bucket permissions. And it tells you right here if it's public or not. And then you can go down and you can add a member. So this kind of looks like that IAM thing, and it's all users like that. Once you give it access to all users and whatever role, and you generally never want to give write access to all users because that means people can use your bucket as a dumping place and you're catching the bill. So don't ever do write access, but read access is fine. So we'll select a role and we'll say cloud storage, and we'll say viewer. Viewer is read access. And now everything in this bucket is going to be public. And are you sure you want to do that? Yes. Again, make sure you don't put your credit card numbers in a public bucket. So voids bucket is there. If you go, oh no, I don't want that bucket anymore, then they make you type voids bucket to get rid
So
of
I could
it.
see this being used if, well, let's say that your group is working on a particular project that has a larger data set, or there are various people doing various what they're called data carpentry or cleaning up data, and you need a centralized location where all those files can be accessed by everyone. So even if you aren't using the Google Cloud compute part of the platform, you may want to use this storage or create a bucket that everyone in your team can use.
Yes, exactly. And again, for the hackathon, you can use a bucket, you can share stuff there. Now there's some interesting things. Now we've got about 10 minutes left. I want to go over some tools that we'll also make available that are useful to learn. So one of the things, and then I'll go back to some advanced features because I want to make sure I don't forget the tools. So there's something called Quick Labs, and Google bought Quick Labs a few years ago. And what it is it's a training platform, an online learning platform where you can easily go through step-by-step learning things. Check. While that's loading. One of the things that you can do is Quick Labs is offering this 30-day all-you-can-eat buffet of all their training materials. So if you go get signed up, you can use it, to get ready for some things before the hackathon, and then do it after. And what's kind of cool about it is, so setting up and creating a Google Cloud. So notice they have a Cloud IAM quick start. So if we go click on that hands-on lab, and when you get to the hands-on lab and you say start lab, and I haven't enabled my credits yet, so I'm not going to do that because I don't have any credits until I do that, but I'm not going to walk you through that, is they kind of tell you, okay, here's an introductory class you should take before this. Here's how you set things up, and this is what they're going to walk you through. But when you actually click that Start Labs thing, they dynamically generate you a Google Cloud environment that then you can go in and play. So just like you saw the console there, depending on the activities they have you do as part of these tutorials or hands-on labs, then you can do that. And I don't know why it had me
Now
on.
this, I really want to reiterate this one. So I have learned just about everything I know about cloud computing from Quick Labs. The really cool thing about Quick Labs is what Boyd was saying right there. When you start a lab, it gives you a username, a temporary username and password. And then you go to the actual Google Cloud Compute platform and perform the steps in real instances using the real interface. It isn't a sandboxed anything. So that way you're truly able to go through and perform these actions as if you were doing them for your own project. So Quick Labs, personally, I think it's an amazing product. And the fact that you get 30 days for free, please take advantage of that, because the other cool thing is it will give you a certification. It can actually give you a certification that you can put on your resume or on your personal profile.
Yeah, and they have different paths. I mean, so this is a great tool to learn and understand and grow. And there's things beyond what I showed, and we'll show that in a minute. So here's multiple VPC networks, all these things you probably won't need for the hackathon, but if you're really deploying and you like these things, they're good to understand, and you can learn the concepts as well as the practical application of it. You can even do things like Kubernetes engines. So there's lots of stuff here, and they call them quests, if you saw that. And so there's introductory and advanced and expert. So probably if you're new to this, you want to start on the introductory. I should have clicked on that one. Here's how to use the Cloud Console. Here's how you do the CLI SDK with cloud storage. Then this is the basic Cloud IAM. And then there's something called Cloud Functions. So what Cloud Functions are is pretty cool. So you saw in the bucket, you could actually write code and you can upload it as a function, and then you can tie it to like a web service or other things that access it. So when someone hits that, it actually runs that function, and then it can access things that are sitting in the bucket. But it's a way of having code, and they've managed all the server and everything else underneath for you. So that's kind of an interesting concept. Pub sub is more of an advanced topic when you have multiple things that need to stay in sync, and and so you publish information that other things listen to and happen. And then there's some other things like AI/ML in here. So there's kind of like infrastructure as a service, then you start getting up to platforms. We kind of consider Cloudy Cluster a platform. Then you could get to things like Google's AI/ML stuff. That would be a platform where you actually do stuff and do specific activities. So we will make sure all of this information gets out, and we'll put links to probably on the website. And there's several other, quick starts. There's the IAM, the Kubernetes engine, the cloud monitoring, cloud functions. We showed those before, and we'll have links to that. And there's also a quick labs for education. So once you burn the 30 days, if you still want to do stuff, there's also 200 credits that you can get that you don't have to burn. And if you are teaching classes, they'll actually give you 5,000 credits for your class and your students. So it's actually a very interesting thing, and they give you time towards that. So these are good ways to kind of extend and go beyond. But now that you've seen the console, you've seen a VM, you've seen the cloud storage, and you got used to the console, now these other things won't be as daunting. But that's what I wanted to cover. If there's any questions, let me know.
So Boyd, I'm going to pop up one more screen here. If you'll stop sharing. Back to my screen, that window.
Jamie,
There we go. All right, go ahead. We had a question.
I was just going to mention that we also published a blog article recently on how to use GCS storage with Cloudy Cluster. Like the example you were saying, if the teams go out and access some of those data repositories that Josh has aggregated on the hack site, and they want to pull that data set down and then do some stuff, but then they get their Cloudy Cluster in, running, and they want to start actually doing the compute. I've got an article with some tips on how to pull that data straight into the compute nodes.
Oh, perfect. Rich, would you mind adding that to the chat window? And I will make sure that all of these links get added. So Josh will be getting an email from me later. One thing I didn't do that you should always do immediately following someone giving a presentation is to say, Boyd, thank you so much for your presentation. Thank you for letting us know about Google Cloud. Google Cloud has a lot of power. Like a lot of power. We've had teams use it for everything from speech recognition to using it for Jupyter notebooks to using it for web servers. And the list goes on and on. Of course, using it for clusters using Cloudy Cluster, which you'll see how to do, you'll learn how to do next week. The fact is, it has a lot in it, as you can tell. That's why we wanted to make sure we pointed out that Quick Labs, so that's quick with no C, because and no U. So QWIK, there we go. Quick, QWIKLABS.com. I highly recommend you take a look at that because there is just so much there. It's honestly, it can be overwhelming, but I would at least recommend taking a look and see if there's anything that interests you. Having said that, Boyd, thank you so much for going over that. I'm going to go ahead and stop the recording now, but then we're going to open it up for any further questions. So go ahead and stop sharing. And then I can hit